Welcome back, everybody. In this video, we're going to start Chapter 6, which is on polynomials. As always, when we start a chapter, we would like to take a look at what we're getting into before we get into it. So in Chapter 6, there are 7 sections, and we'll be covering all 7. Chapter 6 is about polynomials. The entire subject is more working with expressions and less kind of application or word problem oriented than some of our recent experience. The 7 sections we're looking at, once we know what a polynomial is, 6.1 is about adding and subtracting polynomials. And then 6.7 is about exponent rules, and we'll need some of those exponent rules to help us multiply polynomials. 6.3 is about multiplying polynomials. 6.4 is this special product, so there's specific kinds of multiplication problems that we'll see involving polynomials, and 6.4 deals with those. 6.5 is about dividing monomials, and 6.5 is about dividing polynomials. So basically, the first 6/7 of the chapter are about what's a polynomial, how do you add, subtract, multiply, and divide them. And then finally, 6.7 has to do with integer exponents. So there we'll have a meaning for negative exponents. And also we'll see scientific notation and how it can be used to represent really large or really small numbers. For the most part, there aren't as many applications in this chapter, although there are some kind of story problems in section 6.7. Okay, so let's go ahead and get into section 6.1 on adding and subtracting polynomials. In here, this is also the part with the most definitions. As you recall, the beginning section of each chapter is always where things are defined, and so there's lots of definitions to begin with. Okay, so bear with me a couple minutes. Okay, so first of all, a term in math is a constant or product of constant and one or more variables. So examples would be 12, 7x, negative 11y cubed, or 2ab. Those are all examples of terms, things that you get when you multiply. If you multiply a number or letters or numbers and letters together, you get a term. Notice here, this is an instance of where we take an everyday word, like the word term, and give it a special math meaning. You could have the word term in like your geology class where they talk about the terms for volcanoes or whatever. And here the word term has a specific math meaning, and it's a product of stuff that we're multiplying together. By contrast, if you had 7x plus 3, that's not a term. It is a sum of a couple of terms, but it by itself is not a term. A term just has multiplication in it. A monomial is a term like a times x raised to the m power, a number times a variable raised to a power. A is a constant and m is a positive whole number. So if the exponent is a positive whole number, you get a monomial. Examples are 6, 17a, 4x squared negative 8z cubed, 1.47r to the 5th power are all examples of monomials. Polynomials are what you get if you start adding together monomials. If you think about how the prefixes work, mono means one, poly means more than one. So polynomials are what you get if you add together one or more monomials. So examples are 5, which is only a single monomial, x squared minus 9, a difference of two terms, 3x squared minus 5x plus 4, pretty good polynomial, 2a to the 6th power minus 5a cubed plus 6a plus 4, another polynomial. Okay. Some more words. Monomials have one term, binomials have two terms, and trinomials have three terms. Monomials, binomials, and trinomials are all kinds of polynomials. It's just that the words mono or the prefixes mono, bi, and tri tell you a little bit more about how many terms there are. The polynomials is the more general word that describes all of these different kinds of polynomials. Okay, so if that's confusing, let me know and we can talk about it some more. Next thing is the degree of a monomial. The degree on a monomial is the sum of the exponents on its variables. For 4x squared, start writing some answers here. For 4x squared, this is going to have degree 2. There's only one variable, and it has an exponent of 2. Negative 7ab, a and b have an implicit exponent of 1, and there's 2 of them, so that would be also degree 2. 12x has degree 1. There's an implicit 1 on the x here. And then 12 has no variable at all. It's a constant, and so that would be degree 0. Constant terms have degree 0. Okay. For a polynomial, the polynomial's degree is the highest of the degrees of its individual terms. So taking a look, 6a squared b plus 8a. There's 2 terms here we're adding. A squared b has degree 3. A has degree 1. So overall, this polynomial has degree 3. 13x cubed plus 4x minus 8. The highest exponent you see among those terms is the 3. This one is degree 3. 2x squared plus 5x minus 11. That one is degree 2. And then for the last one, 8 plus 4x squared plus x cubed. The highest exponent you see there is the 3 on the x cubed, so this one is degree 3. Don't be put off by the fact that the exponent for the x cubed that's in the back. It doesn't matter what order the terms are in. It just matters which is the highest exponent present. Okay, so that takes care of a bunch of definitions. Again, let me know if you have any questions on those. Okay, next we're going to get into how you actually add and subtract monomials. For the first one here, we're going to add 12x squared and 7x squared. And so how you can look at this is basically that we're combining like terms or equivalently using the distributive property. Since this is one of our first ones, I'm going to use the distributive property to show the work on this. 12x squared plus 7x squared will be the same as 12 plus 7x squareds using the distributive property. And then 12 plus 7 is 19. So that's just 19x squared. So you could also sorry about that. I decided to crash again. Okay, so for the next one, we have negative 15c to the 7th plus 8c to the 7th. This will be the same as negative 15 plus 8c to the 7th. And then negative 15 plus 8 is negative 7. So we'll have negative 7c to the 7th. For subtractions, let's try that. We have 8y minus negative 5y. What I would do first is probably rewrite that as an addition. 8y plus 5y. And then once more with a distributive property, that's the same as 8 plus 5y's. And that's 13y. If you were able to jump straight from 8y plus 5y to 13y without writing this kind of intermediate step, that's okay. For our first couple, I'm trying to show a lot of steps here. Okay, moving on. Negative 16k cubed minus negative 5k cubed. That's the same as negative 16k cubed plus 5k cubed. Okay, here we're adding negative 16 of something plus 5 of something. Same thing. So that's negative 11k cubed. Okay. In the next one, we have 3 terms. But you'll notice that 2 have y squareds. 1 just involves m's, though, and not y's. Remember that when we're combining, we can only combine like terms. So what I'm going to do first is rearrange the terms so that the 2 y terms are nearer to each other. So we'll have 8y squared minus 3y squared plus 3m squared. Okay, so now the 2 y terms can be combined. 8y squared minus 3y squared is 5y squareds. And then we'll still have plus the 3m squared at the back. And that's it. We can't combine that any further and call it 8 of anything. Okay, so that's just going to be 5y squared plus 3m squared. Okay, We'll see a similar thing happen in this next one. We have negative 3w squared and negative 7w squared. That will be negative 10w squared plus the v squared. Okay, and that's it. Can't go any further than that. Okay, take a minute, pause the video and see about if you can do anything with this one, and then restart the video and see how you did. So this one we have a squared b cubed minus 8a cubed plus 4b squared. On this one, there's nothing that can be done. The a squared b cubed and a squareds and b squareds are all unlike terms, so that is already finished. We can't combine that any further. So these few examples have been about combining monomials. So essentially we saw that we just are combining like terms or using the distributive property. You'll notice also that throughout the exponents have never changed. For example, when we did negative 15c to the 7th plus 8c to the 7th, it still was c sevenths. You don't do anything like add exponents or anything like that. You're strictly working with the coefficients. Okay, so now we're ready to add and subtract polynomials. For polynomials, we're going to do basically the same thing. We're just going to combine like terms. So let's try this one. We have 5x squared minus 3x plus 15 and 3x squared minus 4x minus 11. So I'm going to first rewrite that without the parentheses. The parentheses here don't serve to do very much. They just kind of really highlighted that it was two different polynomials we were adding. Now, remembering that addition is commutative, we could go through and rewrite this to put all the like terms near each other, but I don't think that's necessary. 5x squared plus 3x squareds will be 8x squareds. And then we'll have x's, negative 3x minus 4x is negative 7x's. And then finally the constants, 15 minus 11 is 4. Okay, and that will do it. By the way, that you'll notice these marks I'm making under these terms, there's nothing special about the marks I'm making there. The only reason I'm doing that is to partly show you which terms I'm combining and also mark off the ones that I've used so that I know that if there's a term left here that doesn't have a mark under it, that I've forgotten one. And so this way I can tell, okay, I've gotten all of them. You may have had teachers in the past who have crossed things out as they combine like terms. I tend to not do that, partly because I think it's easier to read if you're trying to follow along. Plus, if I have to redo things, then it's easier just to erase the marks underneath. Okay, so that's in case you're wondering why those marks are there underneath. Okay, so next we're going to try a subtraction. We have 8y squared plus 3y minus 19 minus 7y squared minus 14. So what will happen first is I'm going to rewrite this, distributing this minus. So minus 7y squared, and then minus negative 14 will be plus 14. Okay, so now we're ready to combine our y squareds first. So we have 8y squareds minus 7y squareds will be 1y squared. And then y's, there will be just three y's, I guess. And then numbers, we have negative 19 and 14. That's negative 5. Okay, and that's basically it. You'll notice when I'm combining terms, I start with the highest degree terms and work my way down to the lowest. That way my answer is guaranteed to come out in what's called standard form, where the highest power is listed first and they count down from there. Okay, so we have one more. This one has some wording in it that we've got to be careful of. Subtract 5p squared minus 6p minus 2 from 7p squared plus 6p minus 4. Take a minute, try that, restart the video, see how you've done. All right, let's see how you did. Often, you have to be really careful in working with subtraction because subtraction is not commutative. And so let's think about this for a second. If we're going to subtract 3 from 8, how would you calculate that? You're starting with 8, and you're going to take 3 from that. So that would be 8 minus 3, or 5, right? So there should be an equal sign here. 8 minus 3, or 5. So when you subtract 3 from 8, that's not going to be 3 minus 8, okay? Subtract 3 from 8 translates to 8 minus 3, and you'll notice that the word order here is the opposite of the order that it's in when it is turned into an expression. So when you do our given example, we're going to be starting with the 7p squared plus 6p minus 4, and we're subtracting 5p squared minus 6p minus 2 from it. So in all likelihood, you just did this left to right. It's fine. A lot of people do. But you want to try to work on being careful about that. Subtract from the order the expressions end up in is different from how it reads. Okay. So then let's finish that off. We have 7p squared, 6p minus 4. Distributing the negative, negative 5p squared plus 6p plus 2. Okay, and so then we're combining here's 7p squared minus 5p squared will be 2p squareds. And then 6p and 6p is going to be 12p. And then in numbers, we've got negative 4 and a 2, and negative 2. Okay. All right, and that will do it for that one. Okay, so let's see another example. In this example, I wanted to highlight a different way of organizing the work. Instead of just writing from left to right, you could mirror the way that we do addition with numbers. If you're going to add 313 and 516, we stack those, right? So that you add them according to their place values, so that you add the hundreds together, the tens together, and then the ones together. We can do this similarly with polynomials. So we'll have 5x cubed, 7x squared, minus 4x plus 3. And I'm adding to it negative 4x cubed, 2x squared, and minus 8. The second polynomial doesn't have an x term. Okay, but I can stack those two together vertically, and then we can just add vertically according to like terms. 5 minus 4 is 1, x cubed. 7 plus 2 is 9, x squareds. Negative 4 plus 0 is negative 4 x's. And 3 plus negative 8 is negative 5, just in numbers. Okay, and that's how it would look if you want to organize your work vertically. Okay, just a couple more examples, and then we'll be all done with this section. Okay, so here we're to simplify. Simplify essentially means to combine like terms in this case. So taking a look at it, I can see there's a couple of x squared terms. There's some xy terms, which is new, and then a single y squared term. So let me start by rewriting this without the parentheses. So we'll have 3x squared minus 4xy plus 5y squared plus 2x squared minus xy. Okay, so now let's rewrite that, combining the x squareds together. So 3x squared and 2x squared will make 5x squared. Then we'll take the xy terms. Minus 4xy minus xy is negative 5xy. And then finally, 5y squareds. Okay. All right. So next, we're to find a difference. So notice this one doesn't say subtract from, so we're just going to find the difference, just subtract it as written. So we'll have x squared plus y squared. Distributing the negative, we'll have minus x squared minus 5xy plus 6y squared. Okay, so then let me combine the x squared terms first. There's a positive x squared and a negative x squared. Those will add up to 0. Let me take y squareds next. So there's a y squared and a 6y squared. That will make 7y squareds. And then minus that 5xy. And that's it. Okay, last example here. This one, there's a couple things going on. We have three different binomials here. There's first a subtraction and then an addition. So first, let me rewrite this, eliminating all those parentheses. So we'll be distributing negatives where necessary. So we start off x cubed minus x squared y. Now minus xy squared minus y cubed plus x squared y plus xy squared. Okay, so then here, looking for like terms, I can see that the minus x squared y and plus x squared y, those have the same degrees in the variables, but opposite coefficients. So those are going to add up to 0. And also, this is kind of neat, the xy squared and minus xy squared are present. And so those two both are gone. All that's left is x cubed minus y cubed. All right, so that's pretty satisfying when that happens. All right, so then our last topic for this section is evaluating a polynomial for a given value. What evaluate means, what the word suggests, is value, and that's what we're doing is we're coming up with a number this time for an answer, not just another expression. So we're going to replace the variable with a given value and then calculate. So for this one, we have 3x squared plus 2x minus 15. We're going to evaluate it for x equal 3, x equal 5, and x equal 0. So let's try x equal 3 first. Okay, so for x equals 3 first. So that will be 3 times 3 squared minus 2 times 3 minus 15. 3 squared is 9 times 3 is 27. Then we'll have minus 6 minus 15. 27 minus 6 is 21. 21 minus 15 is 6. Okay, and that'll do it. Okay, let's try negative 5. You'll notice as I'm substituting these variables in, I'm inserting parentheses on here just to really make sure that we do our order of operations correctly. Essentially. So definitely a good idea as you replace a variable with a value to wrap that value in parentheses. Okay, negative 5 squared is 25 times 3 will be 75. And then negative 2 times negative 5 will be positive 10. And then we have minus 15 in the back. 85 minus 15 is going to be 70. Okay, evaluating for 0 is always a treat. Multiplying by 0 is fun. Adding 0 also fun. For this one, we're just going to get negative 15 in the back. And that's it. Okay, last thing, this looks kind of like a word problem, but it's not too bad at all. It's the polynomial negative 16t squared plus 250 gives the height of a ball t seconds after it's dropped off of a tall building. When find the height of the ball after t equals 0 seconds and after 3 seconds. Okay, well, after 0 seconds, that implies like right when it's thrown, maybe. So when t is 0, we have negative 16 times 0 squared, it's 250. That's negative 16 times 0, or 0. And that is just 250. Okay, so that would be the initial height of the ball. After 3 seconds, we'll have negative 16 times 3 squared, that's 250. Negative 16 times 9, that's 250. Negative 16 times 9 is negative 144. Okay, so then I need to subtract to get that. 250 minus 144. That's 100 and sorry, I can't go left to right this time because a borrow is needed. Sometimes I subtract from left to right when there's no borrow needed, but this time a borrow is needed. Okay, so that's going to be 106, looks like. That's in feet. All right, so excuse me. That takes us to the end of this section. Let me know if you have any questions, and then have a great day.